Yes, okay, it's fine. Okay, it's being recorded. As I told you, we can Lina will discuss her topic for today اللي هو her journey بال artificial intelligence, especially she will apply it يعني the field of application for her artificial intelligence algorithms are being applied to autonomous cars to predict the pedestrian behavior, right, Lina?
Yes. So in this presentation, I will talk about my journey through artificial intelligence, and especially about my PhD thesis topic, which is on autonomous cars that were able to predict the future using AI. So first, for who am I? I'm Lina Achaji. At the end of my first PhD year between Stellantis group and Inria. And just to have an idea who is Stellantis, it's a group for multiple car factories, including, for example, Peugeot, Citroën, Fiat, Opel, and many other marks. Mm-hmm. And for Inria, it's a research center all over France with multiple branches, and focusing mainly on computer science and IoT and AI applications. And in my thesis, I'm interested in the prediction task for autonomous driving. Mm-hmm. So I'm interested in how autonomous cars will be able to predict the behavior of its environment. And I will do that using artificial intelligence, because there's a lot of method to do it, especially using handcrafted and physical-based methods. But for me, I'm mostly interested in artificial intelligence. So that's what I'm going to talk about. So first, I will give you some history about the autonomous
So you're solving this task from an artificial intelligence approach.
Yes. And also, I will say why it's important to solve it from AI approach. Because, yes. First, let's see how the autonomous cars have really make their way in our daily life, because now for me all I hear about during my life is autonomous cars, and what level we are, and why we are doing that, and why we need it. So the idea of autonomous car was first presented by Darpa, which is a Defense Advanced Research Agency in USA. Mm-hmm. And they proposed to do a race in 2004 with 40 kilometers in a desert in USA. And the idea of the race was non-conventional at all. The race in this event have to be done between driverless cars, so autonomous cars that does not have any driver or a remote control.
Mm-hmm. It's fully autonomous.
Yeah, it's fully autonomous. And in this event, there were more than 100 teams registered from really prestigious academic universities in USA. Mm-hmm. So they tried a lot of things to make it through the race. And here we can see one of the best robots that were presented, which called Sandstorm from Carnegie Mellon. Mm. But as you can see, they were focusing so much on the mechanical and robotics point of view, and also the sensors. Yes. But they weren't so much focusing on software engineering and AI. So the most important thing from this event is that there was no car that won the race, and the race prize was $1 million, and no car was able to win the first race, because it was really hard to do autonomous cars when no one ever have done it before. Mm. So in the next year there was a lot of depression in this way, and we didn't really know if autonomous cars are really a feasible project or not, if they are something from science fiction, or it's really something that we can do using engineering. Mm-hmm. So in 2005, the event was replicated, of course, in some other place, which was confidential. And in this year, there was a team called Stanley, after Stanford, that actually win the race, but the main idea behind their success was that the leader of the team, which is called Sebastian Throne, was a machine learning engineer. He was really interested in software instead of hardware. So after this, after this turning point in the lifetime of autonomous cars,
yes,
we were really sure and that we cannot achieve autonomous driving without going into the AI or machine learning field.
I really love this approach. Like, first they have started without implementing any artificial intelligence, and then they have realized that artificial intelligence is a must to do so.
It was the key for the success of autonomous cars. And after that, Sebastian Throne was team leader of the project of Google for autonomous cars, which is now called Waymo. And from this point on, all the car factories, they were really sure that autonomous car is a way for the future, and we need it in our life.
Yes.
So to discuss more how we can really achieve fully autonomous cars, we have to think about the architecture from a software point of view. So for every driver, if it's a human or a machine, in order to really drive safely and in a good way, we have first to see the environment in front of us. So we have to perceive, and this block is called the perception block. Then
so you have to perceive everything around you, from cars, from pedestrians, from...
Yeah, that's true. And after the perception, we have to put some other knowledge about the environment, which is the knowledge about the future. So if you only perceive your environment in your present time step, you cannot really understand fully what is going on here, because there's a lot of people that believe that the essence of intelligence, not artificial intelligence, the essence of intelligence in the first place is a prediction. So if you cannot predict what will happen next, you cannot really say that you are understanding your world. And the idea here for autonomous cars is really more important because, for example, let's say you have seen a pedestrian or a vehicle in front of you. You cannot plan or decide what you will do next without having in consideration what will happen next to this particular vehicle or pedestrian. So in my thesis, I'm mostly interested in those two blocks, the perception and analysis. And from these two blocks, we can go further for the decision, planification, and control. So we can say that, for example, here we have to decelerate, here we have to accelerate because of some perception of our environment and because of some prediction about what will happen next.
Exactly, and you reminded me of what Einstein has once said regarding the importance of prediction and imagination. He has once said that imagination is more important than knowledge. So the fact that you only perceive using sensors of your autonomous cars, the things around you, is not enough. You have to make some analysis and prediction, and then after, just like how humans behave, actually.
That's right. So we are going to build a driver for our cars, but this driver have to be attentive, has to be solid, have to be robust, and especially have not to do any errors, because honestly, human drivers are not the best drivers in the world. We make a lot of mistakes. Sometimes we were anxious about something, so we don't have all the attention when we are driving, and after that we have a lot of accidents. So autonomous cars will solve this problem by having automated perception and automated prediction.
Yes.
And the only way to do that, from my opinion, is through artificial intelligence. So for the perception block, I don't mean by perceiving our world is that we only have input about the sensors of the cars. no, this is not the only idea because sensors have lower based information about the environment. But what we want really to do is to have a higher level of understanding, like, for example, object detection, semantic understanding of the word, or even maybe pose estimation, classification. And for the prediction, what we want to do is to generate or to imagine what will happen next in our environment. And we want to modelize the behavior of every agent in our environment. So for example, we will have a model for how the cars will behave, how the pedestrian will walk, how the pedestrian will cross the street, and everything like that. And
so it must, I mean, sorry, Lina, if you go back to the other, to the first slide, the previous slide. So here you have to have some rules, like how humans behave, because I guess like it's a pre-knowledge before.
Here I don't agree so much with you, but yeah, at this point I will talk about it later. So about how we can modelize the behavior of every agent. There's some people that go with pre rules, like physics rules, but for me, I'm most interested in learning those rules. So using pattern-based data. So I will talk later about this particular point, but for now, I will also say something that most of the time that we drive in our environment, we drive really in urban places. So it's not only like we have highways and there will be no people or no random events.
The realistic case.
Yeah, what we really care about is how to use those autonomous cars in urban places. Like, for example, here in the Arc de Triomphe, if you know the thing that in Arc de Triomphe there is no lines and also there is no rules, so you have to drive. There is a lot of chaos. And also here, for example, this is a scene from Montreal in Canada. And we can see that there's a lot of importance here to predict the behavior of pedestrians, especially because
roads, yes.
Yeah, because they are the most vulnerable users, and we have to be like we have to make sure that they are safe, and we are attentive so much in order to predict what will be their behavior in the future, because pedestrians have random behavior, have for example, they can change their path instantly. So predicting what will the pedestrian do is not a very easy thing to do.
Exactly.
Yeah. So in order to solve this problem, we have proposed a micro architecture for that. And for example, here, first we have the perception block. Then we have something called data processing and filtering. Then we have the modelizing and prediction and analysis. And at the end, we have something like trajectory prediction or prediction of the intention of each agent on the road.
Like if you want to pass the road or not?
Yeah. For example, if a pedestrian have the intention to cross the road, for example, the autonomous car have to decelerate so that he can cross the road actually.
I guess in this slide you are putting the technology for each task that you have already mentioned in the previous slides.
Yeah, that's
like first you have to perceive using a technology, then you have to process the data and check where the pedestrian is in the data processing technology. I mean the part of data processing, and then you have to model this. Exactly. Okay.
So here I also put it some of the state-of-the-art solutions for doing each of these tasks. So if someone is interested in going further, you can of course read the papers that are mentioned here.
These are the buzzwords. Yes.
Yeah. So for perception, we are mostly interested in object detection, semantic segmentation, and also in pose estimation, because in most of the cases, if a pedestrian wants, for example, to cross the road, he will do some non-verbal gestures like a hand wave or a eye contact or something like that. And in order to really predict his behavior, his future behavior, we have first to understand his skeleton, his body gestures, and all of that.
Mm-hmm.
And from here, we can go to the analysis part. But first, there's also some data processing and filtering. And in my thesis, I wanted also to do this data processing and filtering in an automated way. So I didn't want it to do in handcrafted way.
The manual.
So, yeah, so that all the chain will be automated. And for that reason, here I'm using something called self-supervised or unsupervised learning. And here are some of the techniques that I'm using.
Like if you try to process the images in order to detect where the human is.
This is the first part in perception. But next, I have also, for example, let's say that when perceiving, the perception block is not always perfect. So, for example, if you are using some cameras and you want to perceive what is happening in your environment, you cannot say that you will have a 100 accuracy in the perception block. So we have to do some pre-processing of the perceived higher level data. And let's say that in some cases there's occlusions, or we don't see all the skeleton of the pedestrian, and we want to really go into a model that assume that all the data is perfect. So in this case, we have to put some middle stage, which is called the data pre-processing, and for example, complete the skeleton of this particular pedestrian, and then from this idea go to the model to modelizing what will happen next.
So you have implemented machine learning into sections. Sorry, Iman was saying something.
I have a question here, because are you using online image prediction or processing? I mean, are you taking an image about what's happening in front of the car in 10 meters, 20 meters, 30 meters in order to process all what's happening?
Yeah, I will show you, for example, this image. When we are having images, we have it from an ego vehicle point of view. So, for example, we see a video about from the cameras directly, and this is the video that we see. And then we have on this video, for example, to predict the bounding boxes of every pedestrian so that we can localize him, and also to have an idea about his skeleton, like.
So it's a video processing or an image processing? This is my question. So you're taking a video about what's happening in front of the car and on both sides?
Yeah. For the modeling part, I'm taking the video because I'm taking time into consideration. But here we can have both of them. For example, you can process each image as itself and then go through multiple frames, or you can also do the perception step in time. So there's really the two options, and you can choose the better one.
And do we have really fast algorithms to predict?
Yeah.
Very nice question.
Real-time applications are really the most challenging part in this chain. Yeah, for me, I'm not focusing in my thesis on real-time prediction, but for example, there is a lot of method now in computer vision that focus on real-time perceiving. Like, for example, for object detection, we have YOLO. You can do it really in real time. And also for the pose estimation, you can do it in real time, but you need a really good GPU for that, and so it depends on your hardware.
Yeah, because you need a question of speed, a question of vision, and a question of memory, and a question also of
yeah, that's true.
Technology.
Yes, especially in self-driving cars, so you have to work in real time. Otherwise, you might cross the pedestrian that is crossing the road.
Yeah, sure.
You might hit it.
But also you can.
Sorry.
you can split the problem into phases. For example, you can work on your model, supposing that you are not really working on in real time, and then there will be some other work focusing on how to transform this, for example, models, and make it more simpler in order to apply it in real time.
Okay, perfect.
Yeah. So here I will talk about some of the applications of prediction, like predicting if a pedestrian will cross the road in the future, or what is his intention, if he wants to cross the road or not. So there's a difference here between intention and action prediction. And in order to do that, in order to predict if he will cross the road in front of the vehicle or not, you should already modelize all what is happening before and what will happen next. So it's very related between if you want to predict his future trajectory or if you just want to predict if he will cross or not. There's a lot of shared knowledge here.
Okay.
Question, please. Can you classify, or I don't know, in autonomous cars research in general, are you classifying your research into some researchers are going to study highways, or others are going to study urbans? Or
yeah, that's true. For me, I'm working in urban places.
Okay, so it's really different about, or different depends on the city, or depends on the place that are you studying.
Yeah, that's true. There is a difference between the context. So in urban places, you have more to focus on the context itself, because there will be a lot of chaos, there will be a lot of noisy information coming in and out. But if you are working in highway, it's a little bit easier. So because of that, now for the most of car factories that work in autonomous cars, they have already proposed a lot of solutions for highways, but there is not really a lot of ready to use like products for autonomous driving in urban places.
And which field is more advanced in your opinion now, the urban cars that they are working in urban places, or in city places, like more organized places, highways?
The highways autonomous cars are more mature now, so we already have some products for that. But for the urban self-driving approaches, it's not really very mature for now. So here it's really a very research topic. We are putting a lot of effort to solve this problem, but it's not solved yet.
So we can expect more research in the urban places.
Yeah, a lot of research.
Yes, it seems so.
And for the modeling approaches, to answer the question of Natasha, we can imagine the solution in multiple ways. The first and the classic way is to modelize the behavior of every agent in using a physics-based function. So you can say that pedestrian have this type of velocities, this gate mechanism, and all of that. But
Mechanics.
this is not the best way to modelize the behavior, because pedestrians does not really follow physics all the time. There will be a lot of random.
We are humans, not cars. So
Yeah, that's true. So if we want to apply physics-based approaches, this will give us a very short prediction, like just 2 steps in the future, and then the model will diverge. But there's really 2 more approaches that are interesting, and they need AI in order to be solved.
I guess in physics-based approaches, we're imposing how the human must behave.
Yeah. So we have a lot of inductive biases here, and that's really we don't like in AI words. So
yes.
we don't like to have our pre-knowledge in order to predict what will happen. No, we can really use the data, because we have a lot of data, and if you use them in a good way, we can do something so much more advanced from just physics approaches.
A better modeling of how a human actually crossed the road.
Yes, that's true.
Yes.
So I will have a brief talk about what is the difference between planning-based approaches and sequential-based approaches. So for the planning-based approaches, the first assumption is that every pedestrian or every agent have some predefined goal. So if you are walking in the street, in your head you're saying that you are going to the supermarket or you are going to do some predefined action. You don't really just walk in the street. So the idea here is that if we can predict what is the goal, and then we can planify what the pedestrian will do, conditioning on that the pedestrian will, for example, take the less energy plan or the less costly plan. So here we can say that if we already know the goal, we can planify what will be the future trajectory of this pedestrian. And here we borrow a lot of ideas from reinforcement learning approaches, because in some way what we are doing here is that we are predicting what is the reward function of this pedestrian. So if we can know that a pedestrian will go from places that are not so crowded, and he will take the trajectory that have the less time, and all of that, the criteria. So in some way we are predefining what is the reward function of this agent, or
Yes.
we are discovering what is the reward function of this agent, and we are planifying his trajectory depending on this reward function.
I guess here you're crossing paths with Iman.
Yeah. This idea is called imitation learning or inverse reinforcement learning approaches.
Mm-hmm.
But here, what are the criteria that are you going to expect?
Yeah, the idea here is that we are going to learn the criteria. So instead of defining what is the reward function, we are going to learn what is the reward function of each agent using data.
Okay. More than the time, maybe in the morning you can expect that most of the people are going to work.
Yeah, that's true.
But there are some exceptions, we can say. So this is we are going to learn this how to give a reward to the system such that it can expect the right trajectory of the person.
Exactly. So instead of defining what is a reward like we do in reinforcement, here we are discovering what is a reward. So it's called inverse reinforcement.
Which is so you have two learning systems. One is to learn the reward, and the other is to apply the reward and to learn the trajectory.
That's true. The final approach, which I'm mostly focusing on, it's called the sequential-based approach. And here we focus on the temporal dependencies. So we say that a pedestrian, the question here will be, what is the future trajectory of the pedestrian, conditioning on his previous or history of his trajectories. So if a pedestrian go in this path, so the idea here is what will be his next trajectories, conditioning on this on those states. And here we use a lot of temporal dependencies, and the models that we can apply here can be like recurrent neural network approaches, LSTMs, or the one that I'm really focusing on now is transformers that use attention in order to solve this temporal problem.
Okay. So
yeah.
you're using attention models in order to find solution for this model. What are these attention models? Like
do you want to go more in details here?
No, I was just asking what is the name of these attention models.
For example, you can use attention with some LSTM models, and also you can use attention alone, which is the transformers, which is called transformers.
Yes. And here you are crossing road with
and
Hadi because Shadi is currently working
exactly.
on.
So I have mutual connections with Iman and mutual connections with Chadi. So yeah, here we have
yes,
a
the common
lot
area.
to. So thank you for your attention, and here's my presentation.
Lina, just I have one final question.
Sure.
I'm just curious to know something, because now when we are browsing Google sometimes and we're searching for some products or searching for clothes or whatever, you keep receiving after some minutes some ads about the same products that you are searching. And I don't know, when you said that you are trying to predict where the people are going or the trajectory of each person in the street, are you going to use some data from cell phones, or are you going, or is there a plan to use some data to track people, to track the behavior?
Yeah. So here we have a lot of area for what we call, for example,
Privacy.
IoT or connections between the agents. What we are going really to do is to have information about other cars using connected cars. But the problem, if we have to remodelize what is happening inside the cell phones of each pedestrian. So here we have a lot of problems with privacy, because the first issue for now with autonomous cars is that if we are really preserving the privacy of the pedestrian when we're already filming everything in the road. So using cameras is not an easy way to go, especially in Europe, because there is a lot of regulations for that.
Exactly.
And if you want to also use some data from personal stuff, this will get us into a lot of problems.
Like when you
this is why I'm asking the question, because we are feeling it. I guess it happens with everyone.
Yeah, but for now, I don't know if there's a lot of research going into this direction, because it's not a very robust approach to only predict what will happen next, depending on what is going on inside the phone. So cameras, or also, for example, other sensors like lidars or infrared sensors are more confident. But yes, why not, if in the future, if we really have this autonomous connected utopia, so everything is connecting together, and we can build a lot of things on this layer.
Yes.
Yeah, hello, Lina.
Hi.
Thank you for this interesting presentation. So I have quite some questions. I didn't ask them directly after the slides. So my first question is, when you were talking about the first Darpa challenge, you said that they were interested more about the hardware side or the mechanics side, and they didn't pay attention more to the software side. So they were like interested in the robots rule-based, so like the left right-hand rule, for example.
Yeah, they created a lot of handcrafted rules in order, for example, for the planifications and all of that, they did it manually. So the robot has really freezed in some area and did not continue his trajectory. But here, as we can see from this image, the idea behind the Stanley team is that they are going to fuse all the information from the sensors together, and instead of manually planning what the AV should do, they were relying on some ideas from, for example, Kalman filtering and all of that, in order to plan in a more automated way. And if you want to have more information about that, there's this paper called the robot that won the Darpa challenge. So you can check it and see. Also, there's another book called The Quest to Build the Driverless Car, which is a very important book that focuses on the Darpa challenges and what happened during these challenges.
Very nice.
Okay. Now, when you are talking about because you were like working on the perception side and on the analysis and prediction side. So what is like the type of data you're using? How can you measure the efficiency of your predictions?
Mostly using the images themselves. So I have images, I go into object detection phase and also, for example, skeleton detection phase. And from, so here's the architecture. I have the real images. I go into a higher level representation, and from this higher level interpretation, I can modelize the behavior.
So you are like at the end, you are like let's say measuring the prediction on the initial images you have.
Yes, because in our case, the labels of if you are, for example, predicting the next trajectory of the pedestrian, the labels will be already inside the picture itself. So if you are using some sort of self-supervised approach, you can directly predict what will happen next using only, for example, the coordinates of the bounding boxes. So you don't need to label your data set manually. So the output, for example, will be the next prediction. The input will be the previous images and the previous coordinates and all of that.
So for example, we have like a video captured, a sequence of images. So you have like n-1 images as input and the n image as the output.
Yes.
Yeah. Okay. So my third question is, when you are talking about because the self-driving car or the autonomous car will let's say will in one side or one way it will learn the behavior of, let's say, of humans. So how can you describe the because you mentioned that humans, they make mistakes, so there's like some standards for the mistake. So how can you describe what is the ideal rule for driver? Is there like a criteria you're having that is ideal and the humans make mistakes in this corner?
Okay, the criteria are so much broad. So, for example, you can have your criteria that you want safe cars. You don't want to have accidents, but in this way, maybe you will have non-human-like drivers, because machines can sometimes understand the criteria in some other way than we do. So they can find a lot of hooplops and a lot of those things. So here's the question should is not really targeting my work. It's more targeting this block, the reinforcement learning block. So your question is that what is the reward that we are interested in? Are we interested in human-like driving, or are we interested in safe driving, in more maybe riskier driving? I don't know. So the idea here is how you are going to define your reward function depending on what you are interested in.
Okay.
But of course, the first criteria is the safety. So
yeah, for sure. And now, because mostly of the work when talking about sorry, I'm taking more time in my questions.
No, it's a discussion.
Okay, most of the work, maybe it's easier to work with autonomous cars in the daylight, but what if you face like some low light settings or some night settings when your camera is not very efficient? So what is your solutions for this?
Now there's a lot of work focusing on this type of problems, because for example, the first problem is that in daylight, or for example if you have a bad weather, the perception itself will be harder. So this is a problem. But the other problem in my case is that the behavior of the pedestrians itself will be different, because if you are in some rainy places, you will go faster. Usually you will not have a lot of attention to all the other cars. So here we have two-fold problems. We have the perception one, and we have the
modeling part.
Yeah, the modeling part. for the perception, it's more mature now, because I will give you some sense about what people are doing now. For example, let's say that we have already a data set which is in daylight and in clear weather conditions. What we can do is that we can generate from this data set a corrupted data set or a synthetic data set, where we can add, for example, some effects for having some sort of rain conditions and all of that. And then we can train our model to be more robust in those particular scenarios. So the model now know what is the idea of a rainy weather. And
it's a conditioned model. Like each model has its own conditions to into consideration.
No, we really want that only one model that can solve everything. But
yes,
the main idea here is that how we can see the data, not the model itself. So the model is the same, but we want to create some more data in those high conditions.
Yes.
So if we want
in various conditions, you mean?
Yeah. So the solution here is a data-centric solution, not
yes.
a model-centric solution.
Okay, so in these settings, for example, because maybe in the future we will have like a period of time where all the autonomous cars are connected. Maybe the connection between the cars can be one of the solutions for these settings.
Yeah, connection will add a lot of advantages in our work. But for now, we cannot just say that we'll solve everything with connection, because maybe also in those areas we will not have a good internet connection because of some. So we should always have an alternative solution. And for me, I'm working on the solutions that take into consideration images and try to understand what is happening in the environment.
Okay.
Yes.
Can you please go to the slide when you're explaining the approaches about the physical approach, the planning based, and can you please re-explain the planning based, because I am confused a little bit.
Okay. So here the first hypothesis is that every agent in our environment is rational. So what we mean by rational is that every agent has some goal in his mind. And if you were able to predict what is this goal, so in some way you will be able to also to predict what will be his next trajectories, because if you know the goal and you know that rational like agent will take, for example, the less time consuming road, so you can planify what will happen next. So here we have two main things to discover. The first one is to discover what is his goal, and the second one is to discover what are the criteria that an agent should follow in order to get his goal.
Yes.
Okay, thank you. Also two questions and I finish. First, what are other than real-time, because you are not working on real-time applications, but in your field of research, what are the challenges you are facing?
A lot.
Like the most important challenges, and maybe solved, maybe not yet.
For example, here the perception is not perfect at all. So you should take into consideration that you are going to modelize something that you are not really confident about. So you have to modelize also after each prediction how much you are sure about your prediction. Also, we have a lot of data to capture, because now, okay, we already have a lot of data, but we really need more data in order to understand everything.
Yes.
Especially that if we are working on models that are data hungry, for example, like transformers need a lot of data in order to work. But if they have this data, they will work like a charm. So,
Yeah.
uh, in order to construct a really data set that have all the knowledge inside it, so which is a data set that have a lot of scenarios, that have a lot of diversity, and then you can be sure that your model will work in the right way.
I guess
So
we're
for
all
me,
facing this problem. Like we all want to have this perfect data set that represent everything, and that's the main
yeah,
cumbersome in our work as AI researchers
yeah,
dealing
that's
with data. We have to get our hands dirty on the data.
also, for example, now there's a lot of work done in this area. There's, for example, Andrew Ang now is building a community to just focus on data-centric approaches, because
The famous Stanford researcher, right?
I don't know exactly, but
Yes, I guess.
but yeah, maybe. Because now we really have a very powerful architectures for AI, but what we are not very confident about is data. And when I talk about data, I don't only talk about the first phase of data. I talk about how we are going to use this models with the data, because for example, if we take the special case of transformers, now if we see in NLPs, we have something very powerful, which are the BERT-like models. And
Chadi
those
has worked
models,
on this model, by the way.
yes, and those models does not really differ in the architecture from other transformer models, but they differ in the way that they are interpreting the data, because they follow something called self-supervised learning, and self-supervised learning is the way that we really humans learn. So they transform the same data and the same architecture into something very more powerful, because they know how to use the data in the right way.
Mm-hmm. Yeah. And my last question is your work related like to process the data? Like we are talking on the ground of an autonomous car, you are working like with a connected server, or your work will be, or there are a branch for a future work that the processing will be like some offline models?
No, I don't really focus on this type of work. I'm more focusing on perception, data analyzing, and
okay. So thank you again for your presentation, and hope to hear more about your work.
Hopefully.
You're welcome.
So, are there any more questions regarding?
Yes, we have a couple. So, hello, Lina. Thank you for the presentation. So, I have like just a question, which is like in your group, like Stellantis, do you work on SX? So yeah, so by SX, I mean, for example, like let's say your car has to do an accident, and you have two persons. One is young and the other is old, and he has to choose like the less between these two. So we'll kill the young, or he will kill like. It happens. So
hopefully for me. Hopefully for me, I'm not working on the decision-making block, so it's not my responsibility.
Yeah, but in the group, there are like people like that focusing like on SX, because it's a major
of course.
issue.
Of course, so. there's people working on this type of problems, but yeah, we shouldn't really every time ask this really disturbing question, because if we really ask it, we can ask everything else, like are robots going to kill us in the future, or are we optimistic, or what are robots going to rule our world? And those are the same questions, because we don't really know. We are not yet in this phase. Now we are hoping to have a fully autonomous car that will reduce the amount of accidents and all that, and we are in a happy world. But next, if really the cars have to decide
This
I don't know what will happen, but I'm not in the charge.
Question. So I guess we have like 5 levels, maybe in auto, right?
Yes, right.
So I guess so. When do you think like do you expect like to have like really a fully automated? I guess level 5, not wrong.
Yeah, not.
So do you think like in 5 years, in 10 years, or maybe we're not gonna have like really fully automated, so only like kind of semi-automated?
Yeah, but let me say that for now we are in between level 2 and 3. So we are not yet in level 4. We are not in level 4, and definitely we are not in level 5, because now, okay, we are going into a place where the autonomous car can understand the environment, can understand the behavior, but the problem is that they cannot function in all cases. So you cannot be sure that if you put this same autonomous car, for example, in a desert or in somewhere that has never seen before, that it will really behave. And this is a problem because we didn't really achieve the general intelligence step.
Yeah.
And this problem is not only for autonomous cars, it's the problem of AI itself. So if we
also
can,
an idea.
Yeah.
So yeah, yes, you're right. So but so do you expect like so
for me, I don't expect to have fully autonomous cars soon, but
so yes. So do you think like maybe like the problem will be like having like new kind of architecture, new way of so because you are all so most of us are focusing really on neural networks. So do you think maybe we have like to think something else than neural network? I'm not talking about rule-based or stuff like this, but
yeah.
so to reach like somehow a kind of intelligence.
I believe that maybe the problem is not with the architecture. The problem is with the data itself.
Yes.
So
the problem is data. So also I have like a last question. So because you are working Stellantis, so do you feel like some difficulties like because you are like in a company environment, so there's a lot of things that are confidential.
Yeah.
And you have like do you like have like some issues like when you are publishing because maybe they don't want to share like their data or like their models.
Yeah.
And it happened to you or just like how it happened like in companies. So.
In the group, there's two ideas. There's some people that are going with the open and shared and everything, and there are some people that are more conservative. Of course, you have the two mindsets. For me, of course, I'm with the open-minded approach because I'm going from research-based and all of that. But yeah, for the confidentiality, you have to make sure that, for example, most of the times when we want to publish, we mostly publish first something called patent, so that we can make sure that the ideas are for the group, and then we publish it in a conference in the normal way. Also, there's something very beneficial is that when you are working in a company, you have some team. So you are not working alone. There's a lot of ideas that have already been implemented and you can use it directly. So working inside the team is very beneficial and very powerful.
Sure.
Because you can build on something like a little bit higher.
Yes, not from scratch. I guess, Chadi, do you have more questions or these are the...
Thank you.
Okay, and Iman?
General question at the end. It's about moral decision because I know that autonomous cars are legal in some and I know at the same time that there is a team in MIT, I know some researchers there that they are working on moral decisions of autonomous cars. For example, if the car has in front of it a cat and a person, and of course to kill one of them or to hit one of them, or
Yes.
what's going to be the decision? Or this is just a simple example.
Yeah, I don't know.
I know.
Because I think that no one knows. And
No, but I guess it's a major problem, because here we're on a subject which deals with people's life. It's not as any other technology. So here there's a question: is there a necessity really to do these autonomous cars where we are not really sure if this will be more safe for our lives? Are we going to face a big question here about the legalization of cars?
yes, I think that if we go into a fully autonomous car, of course it will be more safe for our lives, because the amount of accidents that we have every year in every country is really huge. And if we are sure that an autonomous car can behave in all cases, this will be already very beneficial. Also for conformity and time consuming and traffic congestion, those are different approaches. But also if we want to ask the first question about the decision, have you really sometime asked yourself what you will do in such a situation? Because if you are saying that I will hit the cat, or I will hit the person, or whatever, what do you think about your ethical approaches?
Or maybe I can take a decision to kill myself. So here,
Yeah.
Oh my God.
So,
I will hit a tree, for example.
and
So
that
That's why algorithms are all biased. So they are not subjective at all.
not only algorithm, the bias is going from the data, and the data is going from the humans.
An accumulation of biases.
Yeah, because I don't know if you know the study of MIT itself. They are seeing that those biases also differentiate from a country to another.
Yes.
Because, for example, in Europe, they have they mostly focuses on elderly people, so they have a lot of respect for those people. So they
know from the vaccine happening.
Yeah, and in other countries, for example, the people were saying that if someone has non-legal profile, it's okay to hit him. And this is already very.
And but then if the car hit him, what about his family? What are they?
Yeah. So yeah.
That's why I wanted to know just about something.
Yeah, so we really don't know the solution for
It
this problem.
depends. It seems that it depends from country to another, and so it's really tedious.
Yeah, also I have here for me, maybe because Lina is working like in urban areas, so maybe it's a possible solution so the car can stop and
Yeah, of course.
It's not on a highway. In highway, it's more difficult to stop. So
Exactly.
The first step is to take the emergency brake, or also if you can stop before. So all what I'm doing in analysis and the prediction is to prevent those situations from happening. Because if you can predict that something will happen in the future, you can really take the actions more early. But if we are in this situation, I think the first thing to do is to take the emergency brake.
Yeah.
And then maybe the more riskier solutions.
Or we can ask Elon Musk what he will do.
Yeah.
I'm really glad that we had this discussion together, and Lina has shared an awesome work. I hope that you have all liked her presentation and it has been beneficial for you, and you got inspired a bit and more introduced to the field. Thank you, Lina, so much for dedicating your energy and your time on introducing us to your field. I guess it's really awesome. From my side, I hope that you have all liked this presentation, and thank you so much.
You're welcome.